Hi Math, I'm Andy. You've used the Pythagorean theorem to describe the special relationship between the sides of a right triangle. We've also learned that square rooting a number does not always equal a whole number, but we can use the perfect squares that are above and below it to help us estimate that value. So let's say we're given a right triangle that has side lengths 7 and 8, and we want to know what the hypotenuse length is. Well, we know that the Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. So we can substitute the values of the legs, let's just call 8a and 7b, and we can say that 8 squared plus 7 squared is equal to our unknown c squared. So we can go ahead and use our order of operations to help solve for c. Now 8 squared is 64 and 7 squared is 49. That's going to equal c squared. Then we can combine our like terms. 64 plus 49 is equal to 113. That's equal to c squared. But we don't want c squared, we want c. So what we do is we take that 113 and we take that c squared and we take the square root of both sides, because whatever you do to one side of the equation, you have to do to the other to keep it balanced. Now we end up with our c because the square root and the square cancel, and we want to take the square root of 113. Now if we want to estimate this value, I know that 100 is a perfect square. That's less than 113, and 121 is a perfect square, and that is greater than 113. And I know if I take the square root of each of these, the square root of 100 is 10, the square root of 113 is unknown, and the square root of 121 is 11. So the square root of 113 is somewhere between 10 and 11. Now I notice that 113 is 13 away from 100, and it is 8 away from 121. And so because it's a little closer to 121 than it is 100, I'm going to just estimate this as a little more than half. So I would estimate C to have a value of about 10.6. And again, 10.6 is just a little more than halfway between 10 and 11. So we can now use this Pythagorean to estimate. Let's talk about some applications that the Pythagorean theorem can handle. So let's say Coach Kramer's third period PE class is playing baseball. The distance between each base is 90 feet. So kind of looking at our square, we know that from home plate to first to second, it's 90 feet each. Susan is at third base and she throws the ball to Andy at first base. So Susan is here at third base and she throws the ball to first base, straight across. That's where she throws the ball. How far did she actually throw it? Well, if we kind of think about this as a right triangle, I have a 90 feet here and a 90 feet here and an unknown distance in the middle. So again, I know it's kind of hard to see, but we have a 90 feet between first and second, 90 feet between second and third, and we're throwing across. And so here's our right triangle where the legs are 90 and the hypotenuse is unknown. So we can set up our Pythagorean theorem to say that 90 squared plus 90 squared is equal to that distance thrown squared. That's our Pythagorean theorem relationship. And we can kind of do these calculations. I know that 90 squared is 8,100 plus 8,100 equals c squared. Now 8,100 plus 8,100 is equal to 16,200. So that's equal to c squared. Now in order to get c by itself, we go ahead and take the square root of both sides, and you end up with the square root of c squared is c. And now 16,200, that's a pretty big number that I actually don't know the perfect squares that surround it. So instead, what I'm going to do is I'm going to use a calculator to help me figure this one out. So I'm going to take that square root of 16,200, and I find that it's 127.27. So to round this to the nearest tenth, we check the 7, it's bigger than 5, so we'll bump this up, 127.3. Now, because this is a contextual question and it literally asks how far does she throw the ball, we're looking for a distance. And because we're actually speaking in the distances of feet, we can say she threw 127.3. And I might even want to say about, because it's not exact, and I'm going to use the units feet. So anytime you're given like a application problem, a word problem, you always want to answer in context of the problem. Christine and Jackson are now rock climbing. Jackson is at the top of a 75-foot cliff, and he throws a 96-foot rope down to Christine, who is on the ground below. If the rope is stretched tightly from Jackson's feet to Christine's feet, how far from the base of the cliff is Christine standing? So we want to kind of first imagine what's going on. So we'll do some rock climbing here. So we have this kind of rock, and we have our friend standing up here at the top of the cliff. Now we have the ground here, and we have our friend standing somewhere on the ground. Now let's talk about what happened. So Christine, who is at the top, throws a rope and tightly stretches the rope down to our friend Jackson at their feet. So this is going to be our rope. Now the cliff, we're told, is 75 feet tall. So it is 75 feet from here to here. And we're told that the rope is 96 feet. So the rope from here to here is 96. And what we want to know is how far from the base of the cliff is Christine standing. So really this is our unknown distance. This is our, we'll call it x. So we can still use the Pythagorean theorem here. The Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. But in this case, we're missing one of the legs. So I can say that x squared plus 75 squared is equal to 96 squared. And again, because these numbers are pretty large, we're just going to jump our calculator in here to work this out for us. I know that 75 squared is 5,625. So this is 5625, and I can do 96 squared as well, 9,216. So I have my equation that says x squared plus 5,625 is equal to 9,216. I want to solve for my variable x. So I'm going to use inverse operations, and I'm going to subtract 5625 on both sides. I get x squared is equal to, and I'll use my calculator again, 9216 minus 5625 is 3,591. 3,591. Now I don't want x squared, that's the distance that Christine is from the base squared, and so I'm going to take the square root of both sides to get x by itself. Again, I'm going to jump onto my calculator to do this square root, 3591, and I get 59.924. Now 59.924, if I wanted to round that to the nearest 10th place, I would say it's 59.9. And again, because this is a contextual problem, we want to answer the question. It literally says how far from the base of the cliff directly below Jackson is Christine standing, and it looks like that the problem uses the units of feet, and so I would answer this question that Christine is standing 59.9 feet away. So again, you always want to use context. Let's take a look at another application. Bobby has 3 long logs. He wants to place them in a triangle around a campfire to allow people to sit around the fire. The logs have lengths 19, 11, and 21. Can he make a right triangle out of the logs? Well, let's think about that. We have some logs here. We'll try to draw some logs. Little cylinders, I guess we would see. And we'll have a little bonfire in the middle. So, can Bobby make a right triangle around his fire out of these logs? Well, one thing to remember about the Pythagorean theorem is that the hypotenuse is always going to be the longest of the three sides. So this side has to be the side measures 21. Now in the Pythagorean theorem, the legs of the triangle, they don't really matter which one is which. So this can be the 19 and this can be the 11, or you can switch them. It doesn't really matter. But what does matter about the Pythagorean theorem is that a squared plus b squared equals c squared. And this equal is what's really important. This relationship has to work. So what we're going to do is substitute and we're going to check. We'll put in 19 for one of the legs, a squared. We'll put in 11 for one of the legs, b squared. And we'll put in 21 for the hypotenuse, c squared. And we'll just check our math. And again, because these are numbers that are fairly large, I'm just going to jump to my calculator to give me some of these values. So let's do 19 squared is 361. 11 squared, I know that's 121. And 21 squared is 441. So for Bobby to be able to make a right triangle, this has to be true. Let's take 361 and let's add it to 121. I get 482. Now 482 is not 441. And so in math, we have a symbol for something that is not equal. We put a little slash through our equal sign. And because this a squared plus b squared does not equal c squared, we can say that no, he cannot make a right triangle. So because this relationship doesn't check out, he can't make a right triangle out of this. And finally, let's just kind of apply the missing length. We know that a squared plus b squared is c squared. So in this case, x squared plus 15 squared equals 21 squared. X squared plus 15 squared is 225. And 21 squared we actually did in this problem, 441. We're just going to solve for x. I'm going to take away 225 on both sides. I get x squared is equal to 441 minus 225. That's 216. And then I'm going to take the square root of both sides. And the square root of 216 is equal to 14.696938. I'm going to round that to 14.7. So we looked at the Pythagorean theorem, we looked at some applications, and we looked at drawing some diagrams and answering some questions in context.